Hey, welcome back. We are looking at the Check It Out problems 1A and 1B. We're just going to do 1A. For now, they're both quite similar. If you look at the 4 lines given in Check It Out 1A, they're here to the right in blue, green, red, and purple. I want to take a look at the equations in slope-intercept form. We see a slope of 2 here, a slope of 2 there, and we know those 2 lines to be parallel because they're in slope-intercept form. It's very obvious. But let's take a look at these guys, and we'll have a special situation later when we talk about perpendicular. I want you to see that we have 2 equations. One, y equals 0x minus 4, and then x equals. We know this to be linear, but not a function. If you look at the purple line, it goes through the x value at the indicated number. X equals 1 constantly. So over 1, 0, over 1, up 1, over 1, up 2, over 1, up 3. X is constantly 1. And similarly, but completely perpendicular to that, y equals negative 4. The red line, y equals negative 4, is passing through the y-axis at the point negative 4. Same thing, y is constantly negative 4. So when x is 1, y is negative 4. When x is 2, y is negative 4. So we know those 2 lines to be perpendicular, and we're going to talk more about that in the next section. Let's look at page 295. It says the definition for perpendicular lines. The definition is as follows. Perpendicular lines are lines that intersect to form a right angle. So if you look in the room, the corner of the room where the 2 walls meet, that's 90 degrees. The ceiling with the wall, that's 90 degrees. 2 non-vertical lines are perpendicular if and only if the product, meaning multiplying 2 slopes together, yields negative 1. So we can always check just the slopes, multiply them together. If we get negative 1, we know we have perpendicular lines. Vertical lines are always perpendicular to horizontal lines, and we just talked about that. So let's take a look at, this must be example 3. Identify which lines are perpendicular. Well, as we just stated, this is a horizontal, and this is a vertical line, and we know that they are always perpendicular. Y equals 3. Remember what we just said. Y always equals 3. That's all it equals. 3. Never anything else. X is changing. That means no values of the domain are repeating, so we have a function, and it's linear. If we look at x equals negative 2, x is always negative 2. Let's put that one in red. X is always negative 2. When x is negative 2, y is 1, 2, 3, 4, 5, and negative 1, negative 2, negative 3, negative 4, negative 5. And we can see that purple line, y equals 3, and the red line, x equals negative 2, are perpendicular. We'll look right here, forming 90 degrees. We can't compare their slopes. We know this slope to be 0, but this slope we know is undefined. So we can't really find the product of those 2. Let's take a look at the next 2 lines. Y equals 3x and y equals negative 1/3 x minus 4. If we were to graph those quickly, y equals 3x plus nothing, that's a direct variation equation. Our y-intercept 0, and we're going to go up 3 over 1. So we can see, a line, whoa, roughly like that. The other line has y, let's look at this way. We have y minus 0 is equal to negative 1/3 times x minus 4. I just put that in a point slope form, our point being 4, 0. So we have an x-intercept in that line, and we know that we have a negative 1/3 slope. So we're going to go down 1 and over 3, or we could go positive 1 -3. And then when we graph that line through that point, we can see, even though it's a very rough drawing, we can see that is 90 degrees. The other way we can check is to extract those slopes. First slope is 3. Second slope is -1/3. And if I multiply those together, I find a product of -1, which was our definition. Right here, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So we can see that in the case of the second two lines. In the case of the first two, we have to remember that horizontal and vertical are always perpendicular. Please do check it out, problems number 3 and 4 on page 295, and check with me. Make sure that I see them. That's an eyeball with eyelashes. Make sure that I see them so that we know we're on the right track. Example 5 says we're going to write equations of parallel and perpendicular lines. In part A, it says write an equation in slope-intercept form for the line passing through the points 4, 5, and parallel, let's put a parallel sign, to this equation, y equals 5x plus 10. Well, the only thing we need from this equation is the slope. So we're going to write an equation through the point 4, 5 with a slope of 5. Now recall, we want to use our point slope form. We're going to take y minus y1. That's equal to our slope, which we just took out of the other equation, 5 times x minus the x value, x1. And then we're going to put that into slope-intercept form. On the right-hand side, we need to simplify by distributing, and then we're going to add that 5 to both sides, and we get y equals 5x minus 15. So we took a point on our new line and the slope from the other line. I'd like you to check it out, 5a and 5b, and show me 4 points on this assignment. You get 2 points on this assignment for showing me those problems.